Hi guys, a couple of days ago I made a tool. It's called Stylized River Generator. It went viral, a lot of people liked it. That makes me very happy. And some of you asked me how did I make the shader of the water. So today I will show you how to make it. So we will start with the geometry as our land and a curve as our river. And then we're gonna resample it so we can create many points like that. We need these points to recast their position on the land. The recast node switch array from the geometry, the source geometry, to the target geometry. Here's the source position. I added like 50 meters because sometimes the curve, some of it will be under the land, and some part of it will be above the land. So add to the source position this number, I'll move it in the Z up like that, 50 units. And from there, I will shoot ray in the negative direction of the Z towards the land, and that ray will sample the position of the land and apply it to the curve. Then after that, I re-sample the curve in order to get rid of this stretching, because this will affect the texture later. After that, I'll change the normal of the curve to be always perpendicular to the D direction, because the water will never be tilted. It's just always face Z direction. So when I mute this node, you will see that there is a tilt. But when I add it, this tilt is gone. It will make the normal of this geometry always face the Z direction. After that, we'll take the dot product between the tangent and the negative Z direction. The dot product operation is a very interesting operation, and it is very important. Actually, we're going to use geometry node or shader editor. You will need to know more information about the dot product. I'll tell you what I've learned about the dot product, and you can later on search about more information about it. So if we talk the dot product between two curves like this, facing the same direction, the result of this operation will be 1. But if we talk the dot product between two vectors facing the opposite direction, the result will be -1. But if these two vectors are perpendicular like this, the result will be 0. And these two vectors should be normalized, which means their length is 1. So if these two vectors, their length is 1, then the result will be 1 or -1 or 0. So either it's 1 or 0 or -1. And what's in between will be gradient from -1 to 0 and 1. Here in our curve, we will notice that there's some areas are white and the other are black. And the areas are white, that's the one are facing in the same direction with the negative direction of Z. And the other one, which is black, is the ones that are perpendicular to the D direction. With this information, we'll differentiate between the falling water and the flowing water. We will save that, and we later on we will use that in the texture editor. Let's just move to the next step. Then I will add a curve to mesh node, and I will use a curve line as a profile. I will resample the curve profile with the same amount like I resampled the river curve. In the river profile, I will store this information. The spline parameters give you a factor that goes from 0 to 1. I added ping pong operation, which will make it, instead of going from 0 to 1, going from 0, then to the value I specified, which is 0.5, and goes down again to 0. I multiplied it by 2, so the middle of that line become 1, and the edges of that line become 0. If you look at the name of the stored attribute will be the river edge, and that also we're gonna use it later. Let's just keep going now. This is how the river edge will look. It's 0 in the edges, and in the middle, it's 1. And then I captured two attributes, one from the river curve and the other one from the profile curve. I captured the length. The length is a value similar to the factor. But the difference, factor goes from 0 to 1, but the length goes from 0 to the length of the curve itself. And with these two lengths, we will make our UV map. The length comes from the river curve, goes to the X direction, and the one that comes from the profile curve goes to Y direction. If we looked at it, they consist our UV map. X from the length of the river and Y from the length of the profile. Let's move to the most interesting part of this tutorial, which is interacting with the obstacles. So here I do have a collection of obstacles, which I put inside it. This is cube. We're gonna analyze them so they become a real geometry. Then I added a proximity node. This node calculates the distance from the target mesh to the source mesh. If we view it that, it's all one because the distance is very far away. And when I move it like that, the ones which are closer to the obstacles are black. The distance between them is 0, of course. Then I remapped this value from minimum 0 and maximum 0.5 to minimum 1 and maximum 0, which gave me this circle or area around the obstacles. I stored that as an attribute. It's called obstacles, sides, of course, and also we'll use that in the shader editor. But here's something is very interesting. It's how the water interacts with the geometry. It's coming like that. It will goes like in this way. That happens from this setup. Let me show you. So here I just sampled the nearest surface normal, the normal of the obstacles. Then I took the dot product between that normal of the obstacle and the curve normal, which I captured before converting the river curve into a mesh. When you look at the dot product, just let me use this scale node for now. When you look at the result of this dot product, we'll notice that some areas are white and the other are black. And the one which are white, like I told you a couple of minutes before, that's the one they are facing the same direction. So that's the curve. It has this direction like that. And this is the geometry, and it has the normal goes in this direction. Some of this goes towards this one. Some of this goes towards this one. The ones that goes in the same direction with the curve normal will give a result of 1. Opposite directions will give a result of -1. Perpendicular will give a result of 0. And this, my friend, we will edit the UV map. With the geometry proximity, I will specify the area of influence like that, so it's not be the whole mesh. And you will notice here I just multiplied the normal of the obstacles and I made the z direction 0 because sometimes the normal of the obstacles goes towards this area. So when I multiply it, it goes toward this direction. And then I normalize it to give it a value of 1. So it gives an accurate result. So we don't get like small values here. And that's how we distort the UV map. Let me show you in the shader editor because you won't easily notice that. Look at these long stripes, how they interact with the obstacle. That's the result of this UV distortion thing. And that's it for the river. The last thing that I will do for the river is to add some displacement. The displacement will be a scene time node, will be subtracted from our UV map, which we did already stored it here. One goes in the X direction, and another one goes in the Z direction like that, like the W value. But I used the D direction because the D direction has a less calculation time than the W value of the noise. That I scaled this noise distortion with the river edge. You remember the river edge? That's the one we stored it here. So it influences just the areas in the middle like that. Let's move to the land. We're going to add the depths under the river by sampling the river edge from the river. We will sample the river before we distort it. Here I just sampled the near surface in the Z direction. I just multiplied it by 0 to flatten it. And the sample position, I just also multiplied it by 0 in that direction. So when you flatten the sample position, it is the same like if you multiplied the Z direction of it with 0 like that. When both of them became in the same position, we will sample the river edge accurately. It is better than using the ray cast node because the ray cast node is very accurate and sometimes it doesn't give a wanted result. So that is the river edge that we sampled. Then we will scale the normal of the land with this attribute like that to specify the depths underneath the river. The same values that we sampled here, we're gonna use it to distribute the grass. So we're gonna say if it's less than 0.05, we were gonna select that and we will distribute points on that area Then that points become grass. This is the grass collection that I have. You can like grab any photo from and use it for grass. Make sure it is not copyrighted. So the geometry node part ends here. Let's go to the shader editor. In the shader editor, you will notice that I have a driver. This driver, it is hash rem divided by 24. That driver gives us the value of the current frame, which we're gonna use it to animate the noise texture. I have two animations for the UV map, one through the flow and the other for the fall. The same thing like we did here in the distortion with noise in the geometry node. And I have two copies of this node group. It consists the shader of the river. I have these long stripes, which is the noise texture. I multiplied the y direction with 3 to make these long stripes, and feel free to copy the same values. This one, it's another group. It is two Voronoi textures. They are the same, but the difference between this one and this one is F1 and this one is smooth F1. And I take the subtraction between them, which gives me this kind of cost effect. Then I arrange it with a math node set to greater than specific value. And we have this noise texture, which gives me this sort of spot of reflection. I mix between the caustics and these reflections like that. And the last one is this noise texture. This one, I will use it for making this color, the watercolor. So we have long stripes like this one, we have a caustic, we have spots of reflection, we have a color. And that's what's inside this node group. And then I mix between this group with this mix node and a factor of the flow on fall. You remember that attribute? That one that we said will give us difference between the falling water and the flowing water. Let me decrease these values so you can notice it. You see, this goes fast and this one goes slow. The fall shader coming from this node group, I will subtract it from the flow and fall attribute. So it just influence the area of falling water. Then I add mass node set to greater than 0. And here is the attribute from the obstacle sides. Now remember that one, what we've captured from here. Linear lighting with the fall shader. Then I will rearrange it with a math node set to greater than like this one. And this gives me this foam around the obstacles. And this is the flow form. This is how it looks. Remember, comes from these textures. Add them to the obstacles and to the waterfall. All of them together, I will add them to the shader. And here, I mix between the watercolor and the transparent node with the river edge, which we stored it here in the geometry node. So it becomes transparent at the edge of the river. And here I control the watercolor with the value of the noise coming from this node group. That color is moving, and that one is stationary. This will simulate what is underneath the water. It varies, like some spots are dark and some spots are bright. And I mix them between them like that. You see these dark areas, feel like they are under the water. And this moving color, this is the water is moving. Combining all of them together will give us this result. Finally, you have some adjustment you have to do. The material properties of the river, change that from desert, set it to blended, and enable transparent shadows. And also the scene properties, enable ray tracing. And if your viewport looks like that, that's because of the filmic color management. So change it to standard. Filmic is just useful for the realistic scenes. But we do have a stylized scene, so we want the full range of colors. That's how I made the shader of this river. I hope you like this tutorial and see you in the next time. Peace.